Hello students, welcome to the class. So in the previous classes we have discussed about the chapter transistor amplifiers, and now we'll be moving to the next chapter, that is the feedback in amplifiers. Okay, so we are having an idea about the amplifiers now. So what is the amplifier? That is going to strengthen the signal, that is going to increase the strength of a signal. Okay, so there we have studied that the amplifiers will be voltage amplifiers as well as power amplifiers and many other amplifiers in the form of multi-stage amplifier using different coupling and all we have seen that. So now we will be studying about feedback in amplifiers. So we are studying feedback in amplifiers. The next chapter, we are moving to the topic feedback in amplifiers. So now we are studying what? Feedback in amplifiers. So what is feedback basically? Definition of feedback. So what happens in the feedback is that the output of the amplifier is taken. The output, otherwise the part of the output, portion of some output produced by an amplifier is taken and it is applied to the input. Portion of the output is applied back to the input. This is called as what? Process of feedback. So I am going to write the definition of feedback is the process. Feedback is the process of taking some part or portion of the output and feeding it back or applying it back to the input. Feeding it back to the input. Okay, so this is called as feedback. That means the portion of the output that is produced by the amplifier is applied back, otherwise fed back to the input. Right? So the purpose of feedback is basically depends on the type of feedback. Okay, so the type of feedback can be a positive feedback or a negative feedback, where what is the meaning I'll be explaining in detail in the types. But what happens with the feedback for an amplifier? For an amplifier, the feedback works to improve its performance. Improve its performance in the form of avoiding the distortions, avoiding noise. Okay, so this feedback signal is basically the correction signal. Okay, so this is the correction signal that is going to keep on continuously correcting the value of the output. Okay, so this correction, how the correction is obtained is the output produced by the feedback, the output that is in the form of feedback is applied to the input that continuously gives you a access, otherwise continuously give you a reference for correcting any distortions in the signal. Okay, so as we seeing that feedback means applying some portion of the output back to the input. So now the portion of the output, how it is applied, depending on that, the feedback will be categorized. Okay. So before that, I am going to write the definition for feedback amplifiers. Feedback amplifiers. So what is a feedback amplifier? An amplifier signal with a feedback signal is called feedback amplifier. Okay, where the feedback means the output, some portion of the output is given back to the input. Okay. So now we'll be seeing the types of feedbacks. So what is the meaning of feedback? Some portion of the output is fed back, otherwise applied back to the input of an amplifier. Such technique is called as feedback, and feedback types. Now we are going to study types of feedback. Types of feedback. Okay. So there are two types: positive feedback and negative feedback. Positive feedback and negative feedback. Now, what happens in the positive feedback and what happens in the negative feedback? Parallelly, I will explain. So, positive feedback, when the original input signal here means not the feedback signal, the actual signal, input signal to the amplifier. When the original input signal, I'm not distinguishing, I'm just writing the different words. You can also consider it as the difference between the positive and negative. Okay? When the original input signal and the feedback signal are in phase with each other. When the original input signal and the feedback signal are in phase with each other. Okay? It is called positive feedback. Okay? And this positive feedback is also called as direct feedback, or regenerative feedback. Regenerative feedback. So this positive feedback is also called as direct feedback and regenerative feedback. Now about the negative feedback. When the original input signal and the feedback signal are out of phase by out of phase by 180 degree. It is called negative feedback. The negative feedback is also called as inverse feedback, or degenerative feedback. Is also called as what? Inverse feedback or degenerative feedback. Okay. So what is feedback? A portion of the output is applied back to the input along with the input signal. Okay. So the input, the amplifier is actually receiving two types of signal. One is the actual signal and the other one will be the feedback signal. Okay. So the total input that is entering into the amplifier of a feedback amplifier will be original signal plus feedback signal. So the two types of feedbacks are positive feedback, negative feedback. Where when the original input signal and the feedback signal are in phase with each other, it is called what? Positive feedback. Whereas when the original input signal and the feedback signal are out of phase by 180 degree, it is called as negative feedback. Okay, and the positive feedback is also termed as direct feedback and regenerative feedback, whereas the negative feedback is termed as inverse feedback or what? Degenerative feedback, right? So these are the two types of feedbacks. Okay, we are studying feedback in amplifiers, where we have started with the definition of feedback, what is a feedback amplifier, and then what is positive feedback and negative feedback, and the other names for positive and negative feedback. Okay. So I will proceed with the positive feedback now. What happens with the positive feedback is that with the positive feedback, gain increases. Okay. Overall gain of the system, otherwise the amplifier, increases. But what happens at the same time? Noise, distortion, and instability of the signal also increases with the gain. So increase in the gain serves as the advantage for the positive feedback, whereas the distortion, noise, and instability of the signal is going to be the disadvantages for the positive feedback. Okay. The same way in the negative feedback, what happens? Because the signal is negative, the signal gain is not increasing. Signal gain will be reduced. Okay, there will be reduced gain. Otherwise, gain will be, we can say, also constant. It remains constant in the negative feedback amplifiers. Whereas there will be no distortions, there will be reduced noise, reduced distortion, whereas reduced instability in the signal. Okay. So these are the advantages and disadvantages of the positive and negative feedback. So we are studying the positive feedback and the negative feedback. Advantage of positive feedback. Gain increases. Disadvantage. Increased noise, distortion, noise is increased, distortion is increased, and instability. That means signal will be not stable. Instability in the signal. So these are the disadvantages. Whereas for the negative feedback, advantage will be reduced noise, reduced noise, reduced distortion, more stability or more stability. Stability is increases. And also input impedance and output impedance can be varied or we can say selected. Okay, what does this mean? Different types of configurations of the negative feedback is going to give you resulting otherwise various input impedance and output impedance. So depending on your applications, you can go for low impedance, low input impedance, and high output impedance, and vice versa. So you can select between the impedances, input and output, because there are 4 different configurations for the negative feedback where each will be exhibiting different input impedances and different output impedances, and depending upon your application you can select the input and output impedances. Okay, so reduced noise, reduced distortion, more stability, and input and output impedances can be selected. Okay, yes. So now about the disadvantage. The disadvantage is in the form of what? Gain. Yes, of course, another one is improved frequency response or better frequency response. Frequency response will be better. Frequency response will be better. Okay. So the disadvantages is with the gain, because the gain will be not, because of the negative feedback. What happens? Reduced gain. Reduced gain. Okay. Now I will also write the applications for each. It is used in oscillators. Positive feedback is used in oscillators, whereas negative feedback is used in amplifiers. Okay, it is used in amplifiers. Okay, used in oscillators and used in amplifiers. It is not used in them. Because of these reasons, that is increased noise, distortion and instabilities, positive feedback is not preferred for the amplifiers, whereas negative feedback is going to reduce the noise, reduce the distortion, and it is going to make the amplifier more stable. Okay, and frequency response is also improved. For that reason, negative feedback is most popularly or frequently used for amplifiers. Okay. So this is about positive feedback and the negative feedback, right? So what all we have seen here? We have seen the definition of feedback. What is a feedback amplifier? So a feedback amplifier is an amplifier with the feedback signal. So if feedback signal is present, then that type of amplifier is called as feedback amplifier. And what is the feedback? A portion of the output is applied back to the input. That is called as what? Feedback. Moving to the types of feedbacks we have seen, that is positive feedback and negative feedback, where in positive feedback, feedback signal and the original signal are in phase, whereas they are out of phase by 180 degree for negative feedback. Okay. Then about the advantages and disadvantages and the names also. Positive feedback is called as direct feedback as well as regenerative feedback, whereas negative feedback is also called as what? Inverse feedback as well as degenerative feedback. We have discussed the advantages, disadvantages, and applications. Advantages, disadvantages, and applications for positive and negative feedback. Now I am going to draw the block diagram of feedback network. Okay. Exact idea you will get from this. How exactly it is going to operate. The block diagram that shows feedback in amplifiers. So the basic two components, otherwise the basic two blocks for the feedback are amplifier and a feedback network, right? So I am showing you the block diagram of feedback. In amplifiers. So it basically uses two components. The first component is the amplifier. With gain A. Amplifier with gain A. So that amplifier is having the gain of A. Amplifier will be having the gain of what? A. Okay. The next block will be the this will be feedback network. Feedback network with gain, or gain is also called as what? Feedback factor. I will represent feedback network. This can be written as F bar D. That is called as feedback. So I am representing like that in the block diagram. Feedback network with gain or feedback factor. What is the feedback factor? It is denoted by beta. This is denoted by what? Beta. Right? So the two components A and B. That means amplifier with gain A and other block is feedback network with the gain or feedback factor of B. So here two components, otherwise two parameters we have. That is the gain of the amplifier and the other one is the gain of the feedback network. Otherwise feedback factor of the feedback network. Right? Here it will produce the output and the portion of the output is taken and given to the feedback network. Okay. This is the portion of the output. D naught, that is moving towards the feedback network. Next, it gives a feedback signal. It is going to give the feedback signal where the feedback signal is written as Vf and it is given by beta times of V naught. Okay. So the factor by which the output V naught is making it as a feedback factor is making it as a feedback signal is feedback factor beta. Okay. Now the two signals are combined together and passed to the amplifier. And the input to the amplifier is termed as Vin, whereas the signal that enters inside the amplifier in the feedback amplifier is Vi. So this is Vi, where Vi is equal to Vin plus or minus Vn. Why I am writing plus or minus? Because we are not specifying if this type of feedback is a positive feedback or negative feedback. So it can be positive or negative. So this Vf can be in phase or out of phase. So this will be minus Vf. This will be plus Vf. Okay. So this is the signal and this is the block diagram of the feedback in amplifiers, where we see two components. One is the amplifier, where it is having gain of A, and the other is the feedback network with the feedback factor of beta. A portion of the output is given to the feedback network, where it will be converted into the feedback voltage, that is the feedback signal. Vf is equal to beta times of V naught. Okay, and this signal is combined along with the V. This is showing you the summation symbol that shows that the two signals are mixed here, otherwise combined here, right? So that signal is given by Vi is equal to V in plus or minus Vf, because I am not specifying this is a negative feedback block diagram or positive feedback block diagram. Okay, so the signal can be plus Vf also, that means in phase to the input signal and out of phase by 180 degree also. If this signal enters here to the mixer, then that will be a positive feedback. If this signal enters here, then it will be a negative feedback. Okay. So this is about the block diagram and the brief operation of what happens basically inside a feedback amplifier. Okay. Now, in the types of feedbacks, we have seen that what type of feedback an amplifier uses. Now we are clear that an amplifier uses a negative feedback. And what we are studying here, the chapter name is feedback in amplifiers. Okay, what is the chapter name? Feedback in amplifiers. So, what type of feedback we are going to study now in the further topics is the negative feedback. Because what we are dealing with? We are dealing with the feedback in amplifiers, and amplifier uses negative feedback, right? Now, feedback in amplifier. That is a general feedback block diagram, and now we are seeing the block diagram. It remains the same, that is having a amplifier with gain A, and beta feedback network. This is the output. This is VA. This is VI. VI is equal to VA. VI is equal to VA minus VF. Now we are clear about it, that the type of feedback is a negative feedback. VF is equal to beta V. Okay? VF is equal to beta times of V naught. Okay? So now this is a negative feedback block diagram of a negative feedback amplifier. Amplifier with negative feedback, because here we are specifying that it is VE minus VF. Now we are clear that the signal is plus or minus VF. No, it is minus VF. That's right. This is the block diagram of negative feedback in amplifier. Now we will see the four different types of configurations for negative feedback amplifier. Okay. So depending on the feedback applied, if it is applied in the form of series connection or the parallel connection, and the feedback taken is a form of voltage, otherwise a current. Depending on that, we will be having four types of feedback connections. Okay, feedback configuration. So total four types of feedback connections we will study here, where the four different types depends on if the applied feedback signal is a voltage signal or a current signal, and how it is fed. How it is fed? It is fed in the form of series or in the form of parallel. Depending on that, the four types are voltage, series feedback, voltage series feedback, voltage shunt feedback. Shunt means parallel. Okay. Next, current series and fourth one, current shunt feedback. Okay, so the four types are classified like this. Okay, now I will draw the block diagram for each. Voltage is series feedback, amplifier, there is an amplifier with gain A, okay, which is applied with the input voltage. Okay. This is where we are going to take the output. Here we are going to apply the input. Okay. There is a feedback network with feedback factor as beta. Voltage series feedback. How we can call this a voltage series feedback? Because voltage is normally measured in the form of parallel connection. Okay, if you measure a voltage, you have already performed so many practicals in your first year syllabus, that is Ohm's law, KCL and all, where you have used the meters. When you connect the meters, whenever you are measuring a voltage, you will connect it in the parallel form. Whereas for the current, you will be connecting it in the series form. So just imagine like that. It is a voltage feedback, that's why we are taking a parallel connection. Okay? Output. From here I am taking a parallel connection, that means the feedback I am taking is in the form of what? Voltage. Here the feedback is in the form of voltage. Is voltage. Why the feedback becomes voltage? Because we are taking it in the parallel form. Okay? Now the feedback network has received the feedback signal in the form of voltage. I am giving it as an input in the series form. Series, if I connect the same connection here, if I make a same connection here, that becomes a shunt type. Okay, but this type of connection is called as what? Series connection. Okay, voltage series feedback. I am driving a voltage signal as a feedback and I am giving it to the amplifier in the series form of connection. Okay, so this is called as what? Voltage series feedback. Next, voltage shunt feedback. Again, an amplifier with gain A and a feedback network with feedback factor of beta. So the feedback I am taking in the form of what? Voltage. So I am making a parallel connection here. And the feedback has to reach the amplifier in the form of what? Voltage itself. So in the form of what? Parallel connection. That's right. See, both sides I am observing a parallel connection. Feedback side, where I am driving the feedback signal, there also I am giving a parallel connection. Where I am applying the feedback, there also I am having a parallel connection. This type of block diagram is called as voltage shunt feedback. Okay. Whereas output side, where I am taking the feedback, parallel connection. Input side, where I am feeding the feedback, is current type. Then it is called as voltage series feedback. Voltage series feedback. Okay. Now we'll move with the next type. The next type is the current series. Current series feedback, where both the input side connection and output side connection both will be like this. That means the series connection. Amplifier with gain A and feedback network with gain or feedback factor as beta. Input and the signal is taken in the form of series connection, and the feedback is also taken in the form of what? A series connection. So this type of block diagram is called what? It is called as a current series feedback. Last one, current shunt feedback. Where output is taken in the form of series, whereas input will be applied in the form of what? Parallel connection. Gain A, feedback factor beta. Here we are observing V naught, V. Okay. This is the current shunt feedback. Okay. Voltage series, parallel connection at the output side, series connection at the input side. Voltage shunt, input and output both has parallel connections. Current series, input side as well as the output side both will be having a series connection. Okay. Whereas current shunt, output side series connection, input side parallel connection. So these are the four different block diagrams for what? The different types of feedback networks for negative feedback in amplifiers. Okay. So now we'll be seeing the derivation for the gain of a feedback network. Okay. So we'll follow with the block diagram again. Amplifier with gain A. Feedback network with gain or feedback factor as beta. Output portion of output is given to the feedback network. Some portion of the output is fed as BF is equal to beta times of V naught, and Vi is equal to V in minus Vf. Okay, the input to the what? This amplifier will be Vi. Okay, now the entire unit, this is feedback amplifier, and its gain is represented by AF. Okay, and this is the basic amplifier, and its gain is given by just A. Okay, these two things you have to remember. Right? Now I am going to write gain of basic amplifier is. Now see what is the gain of basic amplifier? Ratio output to input. And what is the input? To this, the input to this is Vi. And the input to the feedback amplifier is Vin. Okay? Basic amplifier. Gain of the basic amplifier A is equal to V naught by Vi. Okay? V naught by Vi. Whereas gain of feedback amplifier, that means amplifier with feedback, AF is equal to V naught by V in. That is V naught by V in. Okay, just to see here, V naught by Vi and V naught by V in, because the entire unit is feedback amplifier. Okay, so these two things we have now. Now we will proceed with the expression written here. Okay, Vi is given by, how Vi is given? Vi is given by Vi is equal to Vin minus Vn. Vin minus Vn. Then we can rearrange it to get what? The expression for Vin. So how the Vin can be written? Vin is equal to Vi plus Vn. Where we can further write it as what? Vin is equal to Vi plus Vn. Now see what is Vn. Okay, substitute that. Vi plus beta V naught. Vi plus beta V. From this expression, what is V naught? V naught is equal to A into Vi. Substitute there. Is equal to Vi plus beta into A into Vi, because V naught is equal to A into Vi. V naught is equal to A into Vi. Here only I will write A into Vi. That itself I am substituting in the place of V naught there. Now taking common, 1 plus A beta. V is equal to Vi into 1 plus A beta. Okay. Now, A is equal to V naught by V in. Okay. Substitute this expression if I name it as expression 2 and if I name it as expression 1, then substitute 2 in 1. This I am going to substitute here. So what I am going to make V naught by Vi into 1 plus A beta. That is AF is equal to V naught by Vi is equal to what? A by 1 plus A beta. Okay, so final expression Vf is equal to A by 1 plus A beta. Okay, A by 1 plus A beta. So the final expression that we got for Vf AF is equal to gain of the feedback amplifier is equal to A by 1 plus A beta. Okay, then how we got here? AF is equal to, we substituted V naught by Va, V naught divided by what is Va? Vi into 1 plus A beta. Vi into 1 plus A beta. V naught by Vi is equal to what? A. So AF is equal to A by 1 plus A beta is the final expression that we got it. Okay. So this is about the expression for the gain of a negative feedback amplifier. Gain of a negative feedback amplifier. So this question is a very frequently asked question for exams for 3 marks. This is a fixed type of 3-mark question wherein in this chapter you will be studying another 2 derivations. From these 3 derivations, 1 derivation will be definitely asked in the exam, right? So how the derivation is performed, this block diagram, everything depends on this block diagram because all the expressions are written here and we get the idea of the derivation from the block diagram also. Okay, where I started with the amplifier which is having a gain of V naught by Va, whereas the feedback amplifier is having a gain of AF is equal to V naught by Va, V naught by Vi, V naught by Va, where the gain of the basic amplifier A represented by A is V naught by Vi, whereas gain of the feedback amplifier AF represented by AF is nothing but V naught by Va, right? Now we do the expression for Vi that we can see in the block diagram. The expression that we can see in the block diagram, I consider that and I just rearranged it. Okay, just rearrange it to find the value of Va, where we can see that V is equal to Vi plus Vf. Okay, keeping this side, that goes, Vf goes that side, so it becomes positive, and I'm writing V in this side and Vi plus Vf this side, right? Now what happens? V is equal to Vi plus beta V naught. Why? Because Vf is equal to beta V naught. We can see in the block diagram. I'm just writing that value here, right? And then further, we can write the value of V naught, where from this expression we can see as A is equal to V naught by Vi, V naught is equal to A times of Vi. That simply I substituted here. Okay, the steps are very simple and easy. Again, we can see Vi common here, so I have taken Vi common, and what is remaining in the bracket is 1 plus A beta. Okay, now I have the value of V in, and this V in value I am going to substitute in the expression for AF is equal to V naught by VE. There I will substitute the value, where I can write the value of V naught by Vi as A. So what I will be having the final expression for gain of feedback amplifier, that is AF is A by 1 plus A beta. So AF is equal to A by 1 plus A beta is the expression for the feedback, otherwise the gain of the feedback amplifier. Okay. Now, This is a very, very important derivation. So, till now what all we have seen? We have seen the definition, two types of feedbacks, different types of feedback, negative feedback configurations, four types of configurations we have seen here. Okay, and then we have seen the gain of the feedback amplifier, negative feedback amplifier. Now I will write that expression again. A by 1 plus A beta. Okay, where AF is called closed loop gain. Okay, why it is called closed loop gain? Because it receives a feedback. That's why closed loop gain. Okay, here is called closed loop gain, and closed loop gain can be defined as the gain of an amplifier with feedback. The gain of an amplifier with feedback is called closed loop gain. Okay. Next, where AF is called closed loop gain, A is called open loop gain. Is called what? Open loop gain. And open loop gain is defined as how it is defined? The gain of an amplifier without feedback. Without feedback. Okay. The gain, I missed the word gain here. The gain of an amplifier without feedback. The gain of an amplifier without feedback is called open loop gain. Okay. So these are very important definitions, where these definitions will be asked for 3 marks, where you will be asked 3 definitions. They can ask define closed loop gain, define open loop gain. Okay. The other term is loop gain. Loop gain, where loop gain is A beta, where loop gain is defined as the product of what is A? A is open loop gain. Open loop gain A and feedback factor beta. Okay, the product of open loop gain A and feedback factor beta is called loop gain. Is what it is called? It is called loop gain. Okay, it's called loop gain. Right? So all these terms are in the expression. Right? Next, what is beta? Feedback factor. Definition. It is simply defined as the gain of the feedback network. The gain of the feedback network is called feedback factor. It's called what? Feedback factor. Or it can be also defined as the factor by which the feedback is introduced in an amplifier is called as feedback factor. So we have derived the expression for gain, that is gain of a negative feedback amplifier, that is represented by AF, given as AF is equal to A by 1 plus A beta, right? Where we can see different factors, where we can see AF, that is called as closed loop gain because it is having feedback. Okay. So the gain of an amplifier with feedback is called closed loop gain. Okay. The next term we can see here is A, and it is called as open loop gain. And the gain of an amplifier without feedback is called what? Open loop gain. Whereas the loop gain is the product of open loop gain A and feedback factor beta is called as what? Loop gain. And feedback factor beta is the gain of the feedback network. The gain of a feedback network is called what? Feedback factor beta. So these are the terms that we are observing, otherwise we can see in the expression, right? So what all we have discussed, starting with the definition. From the definition we moved into what is a feedback amplifier. The amplifier with feedback signal is called as a feedback amplifier. So we saw the two types of feedbacks, positive and negative feedback, their advantages, disadvantages and applications we saw. And there we see, there we have seen that the positive feedback is used for the oscillators, whereas the negative feedback is used for amplifiers. Proceeding with the negative feedback, because we are studying feedback in amplifiers. So we have proceeded with the feedback as negative feedback. So in the negative feedback, 4 types of configurations we have seen, and we have seen the block diagrams where we have seen 4 types of feedback block diagrams, where we came to know that the 4 types of feedback configurations are voltage series feedback, voltage shunt feedback, current series feedback, and the current shunt feedback. So all the block diagrams we studied there, right? Then moving to the negative feedback amplifier and the derivation. The derivation for the negative feedback amplifier we have seen, right? So in the derivation, starting with the block diagram, we came to this expression. And in this expression, we have studied all these factors here, right? So this expression we have studied today, we'll be seeing another 2 expressions. That is the expression for the Zin, that means input impedance, expression for the Z0, that is output impedance. We will be seeing the frequency response of a feedback, of a negative feedback amplifier. So how the bandwidth is affected by negative feedback, how the frequency response will be with and without feedback, that we'll be studying. So we'll be coming across various expressions and we'll be solving the numericals, where the numericals will be a 2-mark question, because these are very simple type of numericals, right? And further, after these expressions, we'll be comparing the different types of configurations, that is voltage series, current series, voltage shunt and current shunt. We will compare those block diagrams, feedback networks. Okay. So all that will be proceeding in the next class. So this is about today's class, students. Thank you.